Welcome to Bemanda Podcast, your frontline source for smart, sharp, and straight talk on IT trends, tech truths, and digital transformation. Here is today's podcast in English.
Ever found yourself just drowning in those repetitive tasks, wishing there was some kind of, magic wand to just make them vanish? Or maybe you're already pretty deep into the Power Platform, sort of a pro, but you're looking to take your automation game from, just good to really groundbreaking.
Well, welcome to the deep dive. Today, we're taking a bit of a shortcut to getting really well informed on a topic that's, right at the heart of digital transformation, mastering Power Automate. We're going to unpack its core bits, look at some advanced techniques, and really show you how to build automation solutions that are, truly resilient and smart. And this deep dive, it's specifically tailored for you, our listener, especially if you're a developer, maybe already comfortable with Power Apps, SharePoint, and you're keen to push the boundaries of what Power Automate can actually do. Joining me today, we've got our insightful expert speaker who's ready to connect all the dots, maybe reveal some of the why behind the what's.
Happy to be here. Looking forward to digging in.
And we also have our curious trainee speaker who's here to ask those really essential clarifying questions that, let's be honest, we probably all have.
Yep, ready to learn.
Great. And it's important to mention all the really powerful insights we're sharing today. They're drawn directly from the fantastic Bemanda technology training material on Mess.
Right, it's a really comprehensive resource.
Yeah, we'll definitely be referencing that guide throughout our conversation. All right, so to really get a grip on Power Automate, let's maybe strip away some of the jargon. Let's get to what it really is. Expert speaker, what is this tool? It used to be called Microsoft Flow, right? How is it changing how businesses work?
Right. So at its core, Power Automate is essentially a cloud-based service designed specifically for automating workflows and business processes too. It acts as a bridge,
Right.
connecting this huge ecosystem of Microsoft services, but also third-party ones. The core promise, it's pretty simple, really. Streamline those repetitive tasks everyone hates, boost productivity, cut down on errors, which is a big one,
Yeah.
and ultimately just save people valuable time.
Okay, and for us developers, what's the specific hook? Because, automating tasks on its own sounds a little generic.
It does, yeah.
Okay.
But I think the real power for developers is its dual appeal, you could say. On one hand, it has this super user-friendly interface, which is great for non-developers, empowering citizen developers.
Right, the low-code, no-code aspect.
Exactly. But then it's also packed with advanced features that let us build really sophisticated, complex automation. It allows you to basically orchestrate entire digital ecosystems using configurations and low code rather than writing tons of custom code for every single integration point.
Ah, okay, so it speeds things up.
Massively. It radically accelerates the whole solution development lifecycle. You can deploy complex automations in like days instead of weeks or months sometimes. And it shifts your focus, right? Away from just the plumbing, the connecting gets towards designing truly innovative solutions.
That makes a lot of sense. So it's not just saving time, it's improving efficiency by streamlining workflows, knitting tools together. And that low-code thing means faster development, faster deployment.
Yeah.
And the integration, as you said, goes way beyond just Microsoft stuff, third-party apps, APIs. Okay, so how is it structured? Like, what are the fundamental building blocks?
Well, it's actually designed around a few core components, which makes it quite logical once you grasp them. The central unit, the main thing you build, is the flow itself.
Okay.
Think of a flow as your blueprint for the automated process. There are several different types of flows, kind of like different engines for different kinds of vehicles, depending on what you need it to do. So first up, you've got automated flows. These are kicked off by events.
Events like?
Like a new email arriving or someone uploading a file to SharePoint, maybe a new record being created in Dataverse. A classic example, actually, from the Bemanda training material is setting up email notifications whenever a new item gets created in a SharePoint list. Super common.
Right, okay. Event-driven. Makes sense.
Then you have instant flows. These are triggered manually, like someone actually has to click a button.
In an app. Or
Could be in a Power App, yeah. Or even directly from the Power Automate mobile app or SharePoint. Perfect for something like, say, a manager needing to send out a company-wide announcement right now.
on demand. Got it.
And there are scheduled flows. These run based on time, daily, weekly, maybe the first Tuesday of the month, whatever schedule you set.
Ah, like for reports.
Exactly. Generating daily sales reports every morning is a prime example. Or maybe running a cleanup script every weekend. Next, and these are a bit different, are business process flows, or BPFs. These aren't really about simple task automation in the same way. They're more about guiding users through a structured multi-stage process.
Like a wizard.
Kinda, yeah. Think about customer onboarding or a sales pipeline with distinct stages. BPFs provide that visual guide on top of your data, usually in model-driven apps or Dataverse.
Okay, so more about process guidance.
Precisely. And then for those tricky legacy systems, the ones without nice modern APIs.
Uh-huh. The old desktop apps.
Exactly. We have UI flows.
Yeah.
This is essentially robotic process automation, or RPA. It simulates human actions, mouse clicks, keyboard input. Great for things like data entry into an older system where you just can't connect any other way.
A bit like a screen scraper, but interactive.
Sort of, yeah, but
Yeah.
it actually drives the UI.
Yeah.
And finally, there are custom flows. These are a bit more advanced, usually involving custom connectors. They let you connect to external systems or maybe proprietary APIs that don't have a standard connector available. This really opens up Power Automate to connect to, well, pretty much anything with an API.
Okay, quick question then. If I'm thinking about automating something really simple, like you mentioned getting a notification when a new file lands in SharePoint, which flow type is my go-to there? And like, why that one?
Ah, good question. For that specific scenario, getting notified immediately when a file appears, an automated flow is absolutely your best bet because it's event-driven. The event is the file creation. The moment SharePoint registers that new file, boom, your flow triggers. No need for anyone to click anything or wait for a schedule. It's designed for exactly that kind of immediate event-based reaction.
Right. So the trigger, as you said, it's like the doorbell for your automation. It's the event or the condition that actually starts the flow running. And these triggers can be what? Action-based, like a file creation, time-based for schedules, or a manual, like a button press.
That's spot on. Those are the main categories of triggers.
So, okay, the doorbell rings.
Mm-hmm.
What happens next? What does the flow actually do?
Right. So once that trigger fires, the flow starts executing actions. Think of actions as the actual workers on your digital assembly line. They perform the tasks you've defined in your flow blueprint.
Like sending an email.
Exactly. Sending an email is a very common action. But also things like creating a new record in Dataverse, updating an item in a SharePoint list, posting a message to a Teams channel, calling an external API, manipulating data. Loads of possibilities.
Okay, trigger starts it, actions do the work. But how do all these different bits talk to each other? Like, how does Power Automate know how to speak SharePoint or Salesforce or Twitter? What's the glue holding that together?
That's where connectors come into play. They're absolutely crucial. Connectors are basically pre-built integrations, like little adapters or translators, that allow Power Automate to interact with all these different services and data sources.
So they handle the API calls and authentication behind the scenes.
Pretty much, yeah.
Yeah.
They abstract away a lot of that complexity. And these connectors fall into a few categories. You've got your standard connectors. These cover the most common services, especially within the Microsoft 365 ecosystem. Think Outlook, Excel, SharePoint, Teams, OneDrive. These are generally available with most Power Automate licenses.
Okay, the everyday tools.
Right. Then you have premium connectors. These typically require a higher level license, like a standalone Power Automate plan or certain Dynamics 365 or Power Apps licenses. These give you access to more enterprise-level services or external systems, things like Salesforce, SQL Server, Azure DevOps, Dataverse. Connecting to your core business systems often involves premium connectors.
Right, so that licensing difference is key there. And for us developers, you mentioned custom flows. Does that mean we can build our own connectors? Because that sounds like the real game changer.
Absolutely. That's the custom connectors category. And yes, this is huge for developers. This isn't just about extending Power Automate slightly. It's about making it a truly universal translator for pretty much any service that has an API, whether it's internal or external.
Wow.
So if there isn't a pre-built connector for a niche third-party service you use, or maybe an old internal system with a custom API, you can build your own connector. This really liberates your automation efforts from being limited by just the out-of-the-box options. It lets you build genuinely bespoke solutions that connect absolutely everything you need.
That really does make a massive difference. Okay, quick tip here for listeners. When you are starting out with a new connector, maybe one you haven't used before, always check out the built-in templates first.
Oh, definitely. Good show.
They can be a fantastic shortcut, give you a head start on how to use the actions and triggers for that connector. Okay, let's try a little role-playing scenario now to make this more concrete. Let's say I'm a project manager and I need a really quick way to notify our IT team You can be the IT guru whenever a new project request comes in through a Power App we built, and I need to make sure crucial details get captured automatically.
Okay, sounds like a plan. I'm ready.
All right, so IT guru. I've got this new project request form. It's in Power Apps, works great. But I need a really quick way to just shoot an alert over to our team, with the project name, maybe the client name, whenever a new one gets submitted. What's the Power Automate play here? How do we set that up?
Okay, yeah, easy peasy. We definitely start with an instant flow in this case.
Instant. Why instant?
Because you want it triggered directly from the Power App, right? When your users hit that submit button in the app.
Yeah, exactly.
That action in Power Apps will kick off our instant flow. Then the first thing the flow does is grab those project details. You mentioned project name, client name. It pulls those directly from the data passed by the Power App when the flow was triggered.
Okay, so the app sends the data to the flow. Got it. And then what? How does the team actually get the message?
Right. Once the flow has the data, we'd add an action, probably the send an email V2 action.
Okay.
And we'd populate the email body with that dynamic content we just grabbed from the app, the project name, client name, maybe other details. We can make the email subject dynamic too. Or, even better for real-time visibility, maybe instead of or in addition to email, we use the Teams connector to post a message directly into the IT Teams channel.
Oh, nice. So we could do both. Or choose.
Yep, absolutely. Add multiple notification actions if you want.
So just to clarify, the app itself kind of hands off the information to the flow when the button is pressed. Correct.
And then the flow takes over and does the notification part.
Yeah.
That actually seems really straightforward for getting a quick alert out.
It is surprisingly straightforward for this kind of task. Yeah, that's the beauty of it.
It really is remarkably efficient. Okay, so just to recap that bit, remember, Power Automate acts kind of like a digital conductor, right? Orchestrating tasks across your different apps. It always starts with the trigger,
Yep, the doorbell.
the doorbell.
Yeah.
And then it performs actions,
The workers on the line.
using various connectors to talk to different services.
The translators.
Perfect. Okay, for a little practice, maybe try creating a simple automated flow. One that sends you an email whenever a new item is added to a SharePoint list you use. Good way to see that trigger action sequence. Now, a couple of quick revision questions for you both and for you listening. First one, if you needed to run, say, a data cleanup script every single Sunday night automatically, which type of flow would you reach for and why? For something that has to run at a specific time, like every Sunday night, I definitely use a scheduled flow. Because, it's time-based, not event-based or manual. It just runs when you tell it to.
Spot on. Okay, second question. What's the main difference, thinking about licensing and capability, between a standard and a premium connector? And why would a developer really care about that difference?
Okay. Standard connectors are usually included with the basic licenses, all right, for common stuff like Outlook, SharePoint. But premium connectors, they need a higher license, and they unlock access to more enterprise systems, things like SQL Server, or Dataverse, Salesforce. And a developer cares because often the really critical business data, the stuff you need to integrate with for serious applications, lives in those systems that require premium connectors. So it dictates what you can actually connect to easily.
That's a crystal clear distinction. Excellent. So now that we've got a handle on the different types of flows and how they connect, let's dive a bit deeper. Let's talk about the actual intelligence within the flows. Expert speaker, how do we give our flows a brain? The ability to make decisions, process lists of things, maybe handle errors gracefully when things inevitably go wrong.
Right. This is where it gets really interesting and powerful. We primarily use expressions and functions. Think of these as giving your flow dynamic logic capabilities. So kind of like the advanced formulas you might write in an Excel sheet, but honestly, much more powerful and integrated into the workflow context.
So they let you manipulate data on the fly.
Exactly. Manipulate data, perform calculations, define complex conditions, format text or dates, all that good stuff. And they fall into several key categories that are super relevant for developers. First, you have string functions. Things like concat, to join text together, substring, to extract parts of text, replace, to find and replace text. These aren't just for basic text stuff. They're your toolkit for, say, parsing messy input data or standardizing formats before you write data to a database or call another API. Very useful for data cleansing.
Okay, string manipulation. Makes sense.
Then you have logical functions.
Yeah.
Your basic if, and, or, not. These are fundamental for decision-making within the flow. For example, you might have an expression like if, greater body, 1,000, large order, small order, to categorize an order based on its value.
Right, building conditional logic directly into the data handling.
Precisely. Then there are date and time functions. Super important. Things like UDC now to get the current time, format date time to format dates and times exactly how you need them, add days or add hours to calculate future or past dates. Essential for deadlines, reminders, scheduling logic.
Yeah, date handling is always crucial.
Then we have collection functions. These are vital when you're working with arrays or lists of data, which happens all the time in flows. Think functions like length to get the number of items contains to check if an array includes a specific value, join to combine array elements into a string, or first and last to get specific items. Really powerful for processing query results or lists.
Okay, working with groups of items.
Yep. And finally, there's a category often called workflow functions. These are more specific to the flows context. Things like coalesce, which is great for handling potentially null values by providing a default.
Yeah.
Or good to generate unique identifiers. And trigger outputs are outputs to directly access data from previous steps in your flow.
Okay, you mentioned coalesce for handling nulls. When would I specifically choose that over just using a standard if function to check if something is null? They sound kind of similar.
That's an excellent question, and it highlights a subtle but important difference for cleaner logic. You typically use coalesce when you simply want the first non-null value from a sequence. So if you have a variable that might be null, and if it is, you want to use a default value, coalesce is perfect. For instance, coalesce variables, optional user input, default value, is much more concise and readable than writing an if condition like if empty variables, optional user input, default value, say optional user input.
Okay.
It simplifies the expression, especially if you had multiple potential inputs you wanted to check in order. Coalesce, input A, input B, input C, default, just returns the first one that isn't null. Makes the logic much cleaner when dealing with optional data.
That's a great tip for cleaner code, or cleaner expressions, rather. Okay, so building on that dynamic logic from expressions, how do we control the actual path the flow takes, making it branch or repeat actions? That's where conditions and loops come in, right? They are how you really direct the flow. Conditions are essentially your if-else logic. They let the flow make decisions. Like, if this purchase amount is greater than £1,000, then send it for manager approval. Otherwise, just process it.
Exactly, a standard control flow structure.
And loops, specifically the apply to each control, are for repetition, right? When you need to perform the same set of actions on every item in a collection or list.
Precisely. If you query a show point list and get back 50 items, and you need to update the status for each one, you'd put the update item action inside and apply to each loop, which would automatically run 50 times, once for each item.
So maybe a way to remember this. Think of conditions like traffic lights, directing your flow down different paths based on criteria. And loops are like a conveyor belt, processing each item that comes along in turn.
That's a pretty good analogy, actually. Now, for us developers, building something robust isn't just about making it work when everything is perfect. It's about anticipating failure. And that brings us to basic error handling. This isn't just a nice to have. It's absolutely fundamental for reliable automation. Just like you wouldn't write significant code without try-catch blocks, you shouldn't build significant flows without error handling.
So what tools does Power Automate give us for that?
Two key features right off the bat. First is configure run after. On any action, you can define what the flow should do based on the outcome of the previous action. By default, an action only runs if the previous one succeeded. But you can change that. You can tell an action, hey, run if the previous one failed, or if it was skipped, or if it timed out.
Ah, okay. So you can define specific error paths, like your plan B for every step.
Exactly, your plan B, C, and D. If get items fails, maybe send error notification should run. The second key feature is retry policies. You can configure this on actions that call external services, like connecting to SharePoint or calling an API. If that call fails due to a temporary issue, like a brief network glitch or the service being momentarily overloaded, what we call transient errors, Power Automate can automatically retry the action a configured number of times with a delay between retries.
Oh, that's super useful. It prevents flows failing just because of a momentary blip.
It's incredibly valuable. I once saw a critical daily report flow fail for 3 days straight. Why? A single intermittent network hiccup in an API call that happened occasionally, they hadn't enabled retry policies.
Ouch.
Yeah. Once they turned on a simple retry policy, try up to 4 times with an exponential backoff, the problem vanished. That's when you really appreciate their value. It makes your flows so much more resilient to those common transient issues.
That's a powerful illustration of why it matters. Okay, let's put these concepts, expressions, conditions, loops, basic error handling, into practice with another scenario. Let's say our HR team gets an Excel spreadsheet dropped into a specific folder each week. It contains a list of new hires. They want to automate the initial onboarding steps, but there's a catch. They only want to onboard people listed as full-time in the Excel file, and D, only if their start date is within the next 7 days. How do we build that kind of intelligence into the flow?
Okay, excellent, very realistic use case. Here's how we'd tackle that. First, the trigger would be an automated flow using the SharePoint or OneDrive trigger when a file is created or when a file is created in a folder. We'd point it at the specific folder where HR drops the Excel file.
Right, event-driven again, file appears, flow starts.
Exactly. The next action would be from the Excel Online Business Connector, list rows present in a table. You'd point this at the file that triggered the flow, specify the worksheet, and the table name inside the Excel file that holds the new hire data.
Okay, so now the flow has the list of rows from the Excel sheet.
Correct. It usually comes back as an array or list of items.
Right.
So the next logical step is an apply to each loop. We feed the output, the list of rows, from the list rows action into this loop.
So the loop will process one hire, one row at a time.
Precisely. Now, inside that loop, we add the intelligence. First, we add a condition control. In this condition, we check the employment type. We look at the employment type column from the current item in the loop, which represents the current hire. The condition would be something like item employment type is equal to full-time. Remember, expressions are case-sensitive usually.
Okay, so that filters out anyone not full-time. What about the start date check?
Right. If that first condition is true, they are full-time, then inside the if-yes branch of that condition, we add another condition control, a nested condition. This second condition checks the start date. This is where expressions become vital. We need to compare the hire's start date from the Excel file, let's say it's in a column called start date, with the date 7 days from now. So the condition might look something like this. Item start date is greater than or equal to a TNL, and D item start date is less than or equal to add days now 7. We'd likely need format date time around the dates too to make sure we're comparing them correctly, especially if the Excel date format is tricky.
Wow, okay, so we're using expressions like at T now and add days within the condition to create that dynamic 7-day window check.
Exactly. We're using nested conditions to filter first by employment type, then by start date window, using dynamic date expressions.
And if both conditions are true?
If both are true, they're full-time AND. Their start date is within the next week then. Inside the if-yes branch of the second condition, that's where you put your actual onboarding actions, like create a user account, send a welcome email, add them to a Teams group, whatever the initial steps are.
Okay, that makes sense. But what if something goes wrong earlier? Like, what if the Excel file is empty, or maybe corrupted, or the table name is wrong?
Good point on robustness. We'd use configure run after on the apply to each loop itself, or maybe on an action immediately after the list rows action. If the list rows action fails, maybe couldn't find the table or access the file, we could have a separate branch configured to run only on failure. That branch could then use a send an email or posted Teams action to send an alert to HR or IT saying, hey, the new hire file processing failed for file X, please check it.
That format date time and add days part really clicks for doing dynamic date checks. And using the nested conditions for filtering seems really powerful. It's not just one check, you can chain them.
Absolutely. You could build quite complex decision trees using nested conditions.
They truly are powerful. Okay, quick recap. Remember, expressions are your flow's smart language, giving it the power to calculate and manipulate data. Conditions and loops provide the decision-making and repetition. They're really the brain and the muscle of your automation working together. For some practice, maybe try building a flow that triggers on an incoming email. Use the contains expression inside a condition to check if the email subject or body contains specific keywords, and if it does, use an action to move that email to a specific folder in your mailbox. Now for revision. First, imagine you have a list of invoices, maybe from SharePoint or Excel. You need to calculate the sales tax, say 20% for each invoice amount, and then get a grand total sum of all the packs calculated. What Power Automate feature would you primarily use to iterate through each invoice? And what type of function or expression would be central to doing the tax calculation and summing?
Okay. To go through each invoice one by one, I definitely use an apply to each loop. That's for iterating. For the calculation, I'd need mathematical expressions, like using the MOLA function to multiply the invoice amount by 0.20 to get the tax for each one. And then to sum them up, I'd probably initialize a variable before the loop, maybe call it total tax, set it to 0. Then inside the loop, after calculating the tax for one invoice, I'd use the increment variable action, adding the calculated tax amount to my total tax variable.
Nicely thought through. Using a variable and incrementing it inside the loop is a classic and effective pattern for summing things up.
Perfect. Second question. If an action in your flow, maybe one calling an external web service, occasionally fails due to a temporary network glitch, what built-in error handling feature would you enable first to make your flow much more robust against those kinds of issues?
For those temporary network things, the retry policy, you'd configure that on the specific action making the call. Tell it to try again a few times if it fails.
Fantastic. Exactly right. Okay, let's shift gears now and explore how Power Automate really integrates into the broader Power Platform ecosystem and handles real-world business processes. A really common pairing is Power Automate with Power Apps. We touched on it briefly, but let's dig in. This is where you can build really sophisticated end-to-end business solutions, right? You get the user-friendly front-end UI from Power Apps, combined with Power Automate handling the heavy lifting or complex logic on the back end.
Absolutely. It's a very powerful and, frankly, common combination. It's a symbiotic relationship. As we saw in the scenario, you can trigger flows directly from controls like buttons within Power Apps. This is great for offloading tasks that might be slow or complex if you try to do them directly in the app itself.
Like what kind of tasks?
Well, things like looping through large data sets, making multiple calls to external APIs, performing complex calculations, generating documents, stuff that Power Automate is optimized for and can run asynchronously in the background without locking up the user's app screen.
Right. Keep the app responsive.
Exactly. And crucially, it's not just a one-way street. You can have genuine two-way communication. The app can send data to the flow when it triggers it. The flow does its processing, maybe it creates a record, gets an approval status, calculates a value, and then it can send a result back to the Power App. The app can then use that return data to, say, update the screen, display a confirmation message, or navigate the user elsewhere.
Okay, that two-way communication sounds really useful. How does that technically work? How does the app call the flow and how does the flow talk back?
It starts in Power Automate. When you create a flow using the Power App's trigger, either V1 or V2, you can define input parameters that the flow expects to receive from the app. You use the special Ask in Power Apps option within the trigger card to define these inputs. Then, over in your Power App, usually in the on-select property of a button or maybe another event handler, you call the flow using its name followed by the run function. Inside the parentheses of run, you pass the data the flow expects as arguments in the order you defined them in the trigger. So it might look like your flow name. Run, text input 1.text, user.email, value, slider 1.value.
Okay, so run with parameters sends data to the flow. How does data come back?
To send data back, you use a specific action in Power Automate called Respond to a Power App or Flow. You add this action at the point in your flow where you have the result you want to return. Within this action, you define output parameters, text, number, Boolean, etc., and assign the values you want to send back. Back in the Power App, the run function itself actually returns an object containing these outputs. So you might capture the result in a variable like setFlowResult, your flow name, .run, and then access the outputs like flowResult.output parameter name.
Ah, okay. So the respond action sends it back in the run function call and the app receives it. That opens up a lot of possibilities.
It really does. Common use cases are things like running complex validation logic in the flow and returning true-false, kicking off an approval process, and maybe returning the approval status later, though that needs careful handling of asynchronous nature, submitting data and getting back a confirmation ID, or handling file uploads where the flow processes the file and returns a status.
Very cool. Okay, beyond just app integration, Power Automate is a powerhouse for general automating data processing. Expert, how should we think about this capability? Is it just moving data around?
It's much more than just moving data, although it's very good at that too. I like the analogy of setting up a sophisticated digital factory. Your raw materials, the data come in from various sources. These could be SharePoint lists, SQL databases, Excel files, APIs, form submissions.
Right, the inputs.
Then inside the flow, the data gets refined and shaped. That's the transformation part. You use expressions and specific actions to clean it, reshape it, combine it, calculate new values from it.
Okay, transforming the data.
Then often you need to check it for quality. That's data validation. You use conditions to ensure data integrity, check for required fields, make sure values are within expected ranges.
Validating it.
And finally, the finished product gets shipped out to its final destination. This could mean storing it in a database like Dataverse or SQL, updating a SharePoint list, generating a report file, or integrating it with another system by calling its API. So it really orchestrates that whole data journey, leveraging all the components we've discussed: triggers, actions, connectors, conditions, loops, and expressions.
That factory analogy works well, and Power Automate seemed to have specific tools for each stage. For data collection, it connects to almost anything: SharePoint, SQL, Excel, countless APIs. For data transformation, you mentioned expressions, but there are also specific actions like compose for holding temporary values, filter array to select specific items from a list, select to reshape objects in an array, join to combine array elements.
Absolutely. Those data operation actions are incredibly useful for shaping data without complex expressions sometimes.
And for data validation, we've got conditions and apply to each for checking integrity. For data integration, it's great at moving data between systems. A classic is migrating data from Excel to SharePoint lists, or syncing data between SQL and Dataverse. And for data storage, it naturally works well with SharePoint lists, SQL databases, and especially Microsoft Dataverse.
Okay, now let's focus on one extremely common and high-value use case. Building approval workflows. Businesses need approvals for everything: documents, expenses, leave requests, purchase orders. How does Power Automate make streamlining these review and authorization processes easier?
It offers tremendous flexibility and power here, largely thanks to its built-in approvals connector and actions. You can implement several common patterns easily. There's basic approval, where maybe just one person needs to approve or reject. There's sequential approval, where it needs to go through multiple people or stages in a specific order, like first the manager approves, then finance approves.
Right, one after the other. Then there's parallel approval, where maybe you need approval from 3 different department heads, but it doesn't matter what order they approve in, or maybe you only need the first one to respond.
Okay, everyone gets it at once.
Exactly. And beyond these patterns, you can build completely custom approval logic using conditions, loops, and other actions if you have really unique or complex business rules for who needs to approve what under which circumstances. The absolute central action for all of this is usually start and wait for an approval.
Start and wait. That sounds important.
It is. When your flow hits this action, it actually sends out the approval request, often via email and Teams using the Approvals app, and then the flow pauses. It literally waits right there until the required responses have been received or until a configured timeout is reached.
So the flow just sits there waiting for the human.
Correct. Within that action, you configure who the approvers are, what type of approval it is, like approve reject first to respond, or approve reject everyone must approve, or even custom responses where you define the buttons like proceed send back needs more info. Once the approval action completes, either someone responds or it times out, the flow resumes and you get back the outcome, the comments, who responded, etc. Then you typically use a condition or a switch control right after it to check the outcome and define what happens next based on whether it was approved, rejected, or maybe a custom response.
Great. That start and wait action holding the flow makes a lot of sense for approvals. Let's do another quick scenario to see it in action. Let's say I'm a busy team lead. I submit my leave request through a simple Power App we've built. The request needs to go to the HR manager, that's you again, for approval. Once you approve or reject it, the status of my request needs to be updated in a central SharePoint list where we track leave, and then I need to get an email confirming the decision. So, expert, I've just hit submit on my leave request in the Power App. What happens next in Power Automate land?
Perfect. Another classic use case. Okay, so your button press in the Power App triggers an instant flow. That flow receives the leave details, your name, dates requested, reason, etc., as input parameters from the app using Ask in Power Apps.
Right.
The very next key action is start and wait for an approval. We configure this action, setting the approval type probably to approve reject first to respond, assuming only one HR manager needs to decide. We set the assign to field to the HR manager's email address. We populate the title and details fields with the leave information passed from the app so the HR manager has all the context they need right in the approval request.
Okay, so that sends the request out and the flow pauses.
Yeah.
What happens when HR responds?
Okay, so let's say I, as the HR manager, get the notification in Teams or email, review the details, and click approve. The start and wait for an approval action in your flow now completes. The flow resumes. The action outputs include the outcome, which will be approve in this case, and any comments I added. Immediately after the approval action, you add a condition control. You check if the output start at approval.outcome is equal to approve.
Checking the result.
Exactly. If it is approve, the if yes branch, you'd add 2 actions. First, a SharePoint update item action. You point it to your leave tracking list, use the ID of the request item, which you might have created earlier or passed from the app, to identify the correct row and set the status column to approved. Second, send an email, V2 action, addressed to you, the requester, confirming your leave request for dates has been approved.
Okay, and if you hit reject?
Then the outcome would be reject. The condition control would go down the if no branch. Inside that branch, you'd do similar actions, but with the rejected status. Use SharePoint update item to set the status to rejected, and send an email, V2, to the requester saying, your leave request for dates was unfortunately rejected, maybe including the comments from HR.
That covers the approval logic nicely. But what if, HR is really busy or on vacation and doesn't respond for days? Does the flow just wait forever?
Great point on making it robust. No, you don't want it waiting forever. Within the start and wait for an approval action settings, you can configure a timeout. You can set a duration, like P5D for 5 days. If the approver doesn't respond within that time, the action will complete, but with a timed out status. You can then use configure run after on the next action, like the condition, to also run if the approval step has timed out. This lets you define an escalation path.
Okay, so if it times out.
If it times out, you could have a branch that maybe sends a reminder email to the approver, or maybe notifies their manager, or automatically updates the SharePoint status to escalated for review, prompting someone to follow up manually, builds in that safety net.
So that start and wait for an approval action is really the key piece there. It actually pauses everything until a decision is made or until it times out, and you can plan for both outcomes.
Precisely. It's the intelligent gatekeeper for these human-in-the-loop processes.
That's right. It really manages that interaction point. Okay, quick recap. Remember, Power Automate transforms your apps from just static forms into dynamic process engines. It connects that user input to powerful back-end automation, everything from simple data moves between systems to complex multi-stage approval workflows. For practice this time, definitely explore that. Start and wait for an approval action. Try setting up a really simple document approval flow. Maybe trigger it when a new file is added to a specific SharePoint document library, have it ask for your approval, and then maybe move the file to an approved documents library if you click approve. All right, revision time again. First, describe a scenario where you'd specifically need that two-way communication between Power Apps and Power Automate, where the flow has to pass data back to the app for the user.
Okay, maybe like a product configurator app. The user makes selections in Power Apps for different options. They hit calculate price. That calls a Power Automate flow, passing all the selected options. The flow has complex pricing rules. Maybe it calls an external service or looks up costs in a database, calculates the final price based on all those options, and then it uses the respond to a Power App action to send the final calculated price back to the app. The app then receives that price and displays it to the user on the screen. So the flow does the heavy calculation and returns just the result.
Perfect example. That round trip is essential there.
Huh.
Okay, second question. You need to design an approval process where a legal review must happen only after a finance review has been successfully completed. Which specific type of approval workflow structure would you design in Power Automate and why?
Oh, for that order-dependent one, where legal must be after finance, I'd definitely build a sequential approval workflow. Because sequential ensures that the approval request only goes to the second stage, legal, if and only if the first stage, finance, approves. If finance rejects, it stops there. Parallel wouldn't guarantee that order.
Excellent answers, both spot on. Okay, let's push further now into some of the most powerful and advanced capabilities. Let's talk about automating legacy systems, extending Power Automate's reach, and really future-proofing our solutions. Expert, when we talk about really pushing the boundaries, where do things like UI flows and custom connectors fit into the picture?
They are absolutely essential for achieving comprehensive end-to-end automation, especially in complex enterprise environments. Let's start with UI flows. As we touched on, this is Power Automate's robotic process automation, RPA, capability. Think of it as your digital robotic assistant for tasks where there's no API available.
The Screen Scraper V2.
Sort of, but more interactive. It enables you to automate interactions with older systems, typically Windows-based desktop applications or maybe websites that are hard to automate otherwise. It literally simulates user actions, mouse clicks, keyboard input, reading text from the screen.
So what are the prime use cases for this?
Classic examples include things like data entry into legacy ERP systems like SAP or Oracle, where maybe the specific module you need doesn't have an API, automating tasks in ancient custom-built desktop apps, or maybe scraping data from a website that actively blocks standard HTTP requests. It bridges the gap to systems that can't be reached via standard connectors.
Okay, so it's the fallback when APIs aren't an option. And then for developers, the ultimate power tool, custom connectors. You said this is where we write a new language for Power Automate.
That's a good way to put it. Custom connectors are how developers can integrate Power Automate with basically any external service or internal system that exposes an API, but doesn't already have a pre-built connector provided by Microsoft or a third party.
So if the service has an API, we can probably connect to it.
Pretty much, yes. You can build these custom connectors in a few ways. If the API has an open API, formerly Swagger definition file, that's often the easiest way you can just import it. You can also build them from scratch by defining the triggers and actions manually, or sometimes even import from a Postman collection if you've tested the APIs there. You can even back them with Azure Functions for really complex scenarios.
And the use cases here.
Connecting to niche third-party SaaS applications specific to your industry, integrating with homegrown internal applications that have their own REST APIs, accessing specific Azure services that might not have a full connector yet. Basically, anything with a reachable API that isn't covered out of the box. It ensures Power Automate can truly be the central hub for all your automation needs.
That really does break down the integration barriers. Okay, something else critical, especially for organizations with a history using SharePoint. Converting legacy SharePoint Designer 2013 workflows. Many places still have these running, maybe on older SharePoint sites or even migrated ones. Why is moving these over to Power Automate not just a good idea, but actually becoming a necessity?
Yeah, this is becoming increasingly critical. The primary reason is that SharePoint Designer 2013 workflows are deprecated. Microsoft has officially announced their retirement, especially in the context of SharePoint Online.
Deprecated meaning?
Meaning they are no longer being updated, they are considered legacy technology, support is limited or ending, and crucially, Microsoft is actively phasing them out in SharePoint Online. Eventually, they will simply stop working reliably or altogether.
Oh, wow. So it's a ticking clock.
It really is. Sticking with them means relying on an unsupported, less secure, and less capable technology that's on its way out. Migrating to Power Automate means moving to a modern, cloud-based, fully supported, secure, and vastly more powerful and scalable automation platform. It's about future-proofing your processes.
That's a very strong imperative then. Is it difficult to migrate them? Can we easily map the old SharePoint Designer actions to their Power Automate equivalents?
The good news is that for many common actions, the mapping is quite straightforward. For example, a SharePoint Designer send email action directly translates to Power Automates. Send an email v2 action, which is much more flexible anyway. A pause for duration or pause until date in Designer maps very cleanly to the delay or delay until actions in Power Automate. And the old, somewhat clunky start approval process or start task process actions in Designer are replaced by the much more robust and feature-rich start and wait for an approval action we discussed earlier.
Okay, so common patterns translate well. Are there tools to help?
Yes, definitely. Microsoft provides the SharePoint Modernization Scanner. This tool can analyze your SharePoint environment and identify where these legacy workflows are being used, which helps you prioritize the migration effort. And, as always, Power Automate itself has built-in templates, some specifically designed to replicate common SharePoint scenarios, which can give you a head start when rebuilding the logic.
That's good to know. So for any developers listening who might be inheriting older SharePoint environments, prioritizing the identification and migration of these Designer 2013 workflows really needs to be high on their list for long-term stability and security. Okay, expert, let's get into building truly resilient flows now. Let's talk advanced error handling and monitoring. We covered basic retries and run after, but how do we take it to the next level? What are the common pitfalls, and how do we build flows that can gracefully handle more significant issues?
Right. Beyond simple retries, we need more structured ways to handle failures. Common causes of errors that might need more than just a retry include problems with data validation, like unexpected input formats, persistent permission issues, external service outages that last longer than the retry policy, or maybe critical failures within the flow logic itself. Power Automate gives us several powerful techniques for this. A key one is using scope actions.
Scope, what does that do?
Think of a scope control as a container. You can group a set of related actions together inside a scope. This is incredibly useful for error handling because it allows you to implement patterns similar to try-catch-finally blocks in traditional programming. You'd put your main block of actions, the try part, inside one scope. Then you'd have another scope immediately after it, and you'd configure its run after setting to only run if the first try scope fails. This second scope acts as your catch block, where you put your error handling, logging the error, sending notifications, maybe performing cleanup actions.
Okay. So you isolate the error handling for a whole block of actions.
Exactly. And you could even add a third scope configured to run after the triscope, regardless of whether it succeeded or failed, by checking multiple boxes in run after. This acts like your finally block for actions that must always run, like maybe closing a connection or updating a status log.
That sounds much more structured. What else?
Another useful tool is the terminate action. This allows you to deliberately stop a flow's execution at a specific point. Crucially, you can set the status of the termination: succeeded, failed, or canceled. This is great for situations where, based on some condition or error, you know the flow shouldn't proceed further and you want to explicitly mark the run as failed in the history, maybe with a specific error message.
Okay, controlled stops.
Then there's robust logging errors. Don't just rely on the flow run history. For critical processes, actively log failures to a persistent store. This could be a dedicated SharePoint list, a table in Dataverse, or even a SQL database. Record details like the flow name, run ID, timestamp, error message, maybe key input data. This is vital for auditing, tracking trends, and debugging. Of course, sending notifications for failures is crucial for timely intervention. Post messages to Teams channels, send emails to support groups, make sure the right people know when something breaks. And sometimes, for critical steps, you might even consider parallel branching for redundancy. If you have two ways to achieve something, maybe using different services, you could run them in parallel. If one branch fails, the other might still succeed, allowing the flow to continue. A bit more complex, but useful for high availability.
That's a comprehensive toolkit. And how do we keep an eye on all of this? What are the monitoring tools available?
Monitoring is key. First, there's the built-in flow run history available directly within the Power Automate portal. For every single flow run, you get detailed information, whether it succeeded or failed, how long each step took, the inputs and outputs of each action if configured, and any specific error messages if it failed. This is your first stop for debugging individual runs.
The detailed execution log.
Exactly. For a broader organizational view, there's the Power Platform Admin Center. Admins can get tenant-wide analytics here, see flow usage trends, identify flows with high error rates, manage environments, and configure data loss prevention policies.
So admin-level oversight.
Right. And if you need even more advanced reporting and visualization, you can export the flow run data, perhaps using other Power Automate flows or data export features, and bring it into Power BI. This allows you to build custom dashboards, track KPIs over time, correlate errors with other factors, really deep dive into the analytics of your automation performance.
Okay, quick question on the scopes again. If I use a scope for my main process, like the try block, and something inside it fails, causing the whole scope to fail, how do I make absolutely sure that a specific cleanup action, like logging the error to my SharePoint list, always runs, even if that main process totally crashes and burns?
Perfect question about ensuring cleanup. You'd achieve that precisely using the configure run after settings on your cleanup action, or better yet, put the cleanup actions inside their own scope, your finally block. Let's say you have scope A, scope B, catch runs if A fails. You could have scope C, finally. You'd configure scope C's run after settings to run if scope A is successful, or if scope A has failed, or if scope A is skipped, or if scope A is timed out. Basically, you check all the boxes except maybe the catch scope success failure. This ensures that regardless of what happened in scope A, or even scope B, scope C will execute. So your critical error logging or resource releasing action placed inside scope C is guaranteed to run. It's the essential safety net for cleanup.
That's a really critical piece of the puzzle for truly robust design. Thanks for clarifying that. Okay, pulling this together, let's quickly recap some overall best practices for robust flows based on the Bemanda materials in our discussion. First, plan and document your flows. Seriously, don't just jump in. Sketch it out, add comments in the flow, maybe keep external documentation. Essential for maintainability, especially as flows get complex or when someone else needs to understand them.
Absolutely critical. Future you will thank you.
Second, use descriptive names for your flows and for the actions inside them. Rename condition 2 to check if amount exceeds limit. Makes debugging so much easier. Third, limit API calls and optimize performance. Be mindful of connector limits. Avoid unnecessary loops. Use filtering in your data source queries, like OData filters for SharePoint, rather than pulling everything back and filtering in the flow. Use batch operations where possible.
Performance tuning is key for reliability and cost, especially with premium connectors.
Fourth, as we just discussed, implement scope-based error handling and retry attempts religiously for any non-trivial flow. Build that resilience in from the start. Fifth, secure your flows. Think about the connections used run flows under service accounts where appropriate, and critically understand and utilize data loss prevention DLP policies. Expert, can you quickly explain what DLP policies do in this context?
Sure, DLP policies are configured by admins in the Power Platform Admin Center. They act like a digital fence, allowing admins to define rules about which connectors can be used together within the same flow or app. For example, you could create a policy that prevents a flow from using both the SQL Server connector, potentially accessing sensitive internal data, and the Twitter connector in the same flow. This helps prevent accidental or malicious exfiltration of sensitive data out of your organization's boundaries. They are crucial for governance and compliance.
Right, prevents data leaking where it shouldn't. Very important. And finally, the sixth best practice. Monitor regularly. Don't just set and forget. Periodically review the run history, check the Admin Center dashboards, look for patterns of failures, and proactively optimize your flows. Okay, so to wrap up this section, remember, from simulating human clicks with UI flows to building custom API integrations with custom connectors, and from gracefully handling errors with scopes to visualizing performance with monitoring tools, Power Automate truly empowers developers to build automation solutions that are not just functional but genuinely resilient and scalable. For practice here, maybe design a slightly more complex flow, perhaps one that involves multiple steps and potential failure points. Then, intentionally introduce an error somewhere, maybe provide bad input data or temporarily revoke permissions for a connection. Then, practice using configure run after and scope actions to catch that failure gracefully, log a meaningful error message using also a SharePoint list, and maybe send yourself a notification. Really get hands-on with managing failures.
All right, our final revision questions for this event section. First, when would a developer typically make the decision to build a custom connector instead of just trying to work with an existing standard or premium one? What's the trigger for going custom?
You'd go for a custom connector when the specific service or API you absolutely need to integrate with just isn't covered by any existing connector. Like if it's a really niche third-party app or maybe a homegrown internal system with its own unique API that Microsoft obviously wouldn't know about. If there's no pre-built bridge, you have to build your own with a custom connector, assuming the target system has an API you can talk to.
Perfect. And second question.
Yeah.
Why is migrating those old SharePoint Designer 2013 workflows to Power Automate not just a nice-to-have cleanup task, but actually becoming a necessity for organizations, especially those using SharePoint Online?
Because they're deprecated, Microsoft is phasing them out. They'll eventually stop working reliably or entirely in SharePoint Online, so sticking with them is a risk. Migrating to Power Automate is necessary for future compatibility, security, support, and also just to take advantage of all the much more powerful features Power Automate offers compared to the old Designer workflows. It's about staying current and stable.
Fantastic. You've both nailed those. Well, we have certainly covered a lot of ground today. We've navigated the pretty impressive landscape of Power Automate, haven't we? From its fundamental building blocks, flows, triggers, actions, connectors, and the diverse types of flows for different needs.
Automated, instant, scheduled, BPFs, UI flows.
Right. To mastering expressions for dynamic logic, building sophisticated business processes like data handling and approvals, integrating tightly with Power Apps.
And making sure things don't fall over with error handling.
Exactly. Ensuring our automations are genuinely resilient through robust error handling, monitoring, and best practices.
And throughout this whole deep dive, we really owe a big thank you to the incredibly comprehensive Bemanda technology training material on mastering Power Automate. As we've referenced, it's just packed with details, examples, and best practices. Truly a goldmine if you're looking to build powerful, reliable, scalable automation solutions using this platform.
Absolutely agree. It was an invaluable guide for our discussion today.
So maybe a final thought to leave everyone with. Consider this. If you could identify just one task in your current workflow, something repetitive, maybe error-prone, definitely manual that, if you automated it, would free up significant time for you or your team. Time you could then spend on more valuable, innovative work. What would that one task be? And think about everything we've discussed today. What Power Automate feature, maybe a specific trigger, action, or connector, would be your very first step in tackling it? Something to mull over.
That's a great challenge to end on. Find that first domino to tip over with automation. Keep exploring, keep building, and keep automating. Thanks for diving deep with us today.